All right, so we're back here, and so we're going to talk a little bit about CIs for population proportion. So when we start thinking about this, right, the good news is that things are going to look pretty similar, and this should be fairly easy to digest. So we've introduced this idea that we're looking and we're interested in intervals, right? And we want to kind of symbolize it. So we always have these estimates that we symbolize as like p hat. So this is like an estimate of the proportion we're trying to estimate. We want to estimate. And so when we have that right, when we try and figure this out, it's the exact same thing that we already kind of covered a bit. So things look really similar, and they shouldn't be that complicated, right? So, usually it might be like if we were trying to solve like p hat, we might have this x bar thing, and we might try to find like the standard deviation, which is equal to p 1 minus p. So this complement divided by n and put the square root over it. And this is how we would find that standard deviation. And so looks very similar to what we already covered in this, right? And so there's just a few other little factoids to know about this. So when we move into interval estimation, this works really well. For large random samples. So we have something that's small, or we have something that's not random, and this is technically formula doesn't work. So technically doesn't work if this criteria isn't met. And so beyond that, right, when we talk about like having a large sample array, we're usually talking about greater than 30 sample size. So if we were going to do like an experiment for the probation department, we'd want more than 30 people. If we wanted to look at crop fields for whatever reason, we would want to like look at it with more than 30 people or something like that. And so, but later on we'll see that there is an adjustment to use if necessary. And so something else to consider too is that we've been using 95% confidence. For this interval, right? To say that we're like 95%, like pretty sure in the long run, we'll have guessed it correctly. But it is possible to get 90% or 95% or 99% and so on. All that we do to do this, it requires a small change in formula. And so the way that we would do this, right? So if you remember from our last little video, right? If we have here the CI is equal to x bar plus or minus 1.96 times the standard deviation found for that sample. All that we might do, right, is we would make a small change. And so we might say that the confidence interval is x bar here plus or minus 2.58 times standard deviation. So the only thing that's changed, right, this is the same formula, same setup, are these two numbers right here. And these are z-scores that we use to assess confidence. And so depending on which one we use, we're either going to get either bigger or tighter intervals depending on the number that we use based on the z-score. So if we use put this here, small number is going to be tighter because the multiplicative factor here is there. If it's a bigger number, it's going to be wider or bigger. So that's kind of like the core thing here. So this is just like simple multiplication kind of stuff. And we'll leave a little note here at the end here about a few things, right? So if we wanted 90% confidence, we would make that value 1.645. If we wanted 95%, this value is going to end up being 1.96. And if we wanted 99% confidence, we would make this 2.58. Point being here is that these are the most common used values. Used CI bands is sometimes what they're called. With this one is the most common out of that bunch. Common out of the bunch. So, and the way that we kind of interpret this too is that in the long run, values with repeated sampling will contain the true population mean or proportion or whatever we're testing. So basic point here, right, is that this is it's the same kind of formula that we used. We were still solving intervals and formulas, and we've just shown in here that we can manipulate that range depending on like the level of confidence that we want. So the next video we'll talk a little bit about some examples and how we would go and calculate this.